Hi everyone. In this video I am going to explain about generalized NMOS NAND gate. So generalized NMOS NAND gate, before going into the general format, let us consider what are the main uh, designs of this NMOS NAND gate. So first we will see the basic normal NAND symbol. NAND symbol we know, AND gate followed by NOT, AND followed by NOT. In general representation of the symbolic representations, we generally consider first AND operation followed by a NOT operation. Two gates involved here. These two gates logic symbols. But whereas when we consider in the CMOS structure, the basic structure itself gives you the complemented form. Okay, we no need to go for the two gate realization. One gate that is sufficient, which gives a complemented form. Here it is AB and later it will be AB bar. Okay, so here NMOS means all transistors. It is not CMOS design. In CMOS design, pull up transistors are PMOS and pull down transistors are NMOS. But whereas in the NMOS structure, if pull up pull down both are of NMOS transistors, but whereas pull up device consisting of one depletion mode NMOS transistor which is always in on state, and pull down devices are made up of purely NMOS enhancement modes. And depending upon the realization we will consider the parallel or series. All are NMOS transistors, both pull up and pull down. Okay, next, pull up transistor must be a depletion mode. Pull up transistor must be a depletion mode NMOS. Only one transistor. Okay, I am clearly writing each and every statement so that you can easily design any type of logic circuit. And pull down is pull up where it is connected between VDD and output. Pull down means output and ground. Pull down transistor, here it is the realization must be NMOS enhancement mode. Okay, it is a realization, it is nothing but realization. Suppose if we have like this AND operation, A dot B dot product, it will give you what is that, series connection between two NMOS transistors. Suppose if it is plus operation, then it is parallel connection between two NMOS transistors. How many number of inputs? That many NMOS transistors in the enhancement mode we need. Okay, so for our realization we need a let us consider two input. For example, two input NAND gate. So two input NAND gate which is NMOS type. As I said in the previous case, the pull up transistor must be a depletion mode NMOS transistor. So depletion mode means we have to show a channel here, and thereby, as the depletion mode does not require any input signal because it is always in on state, there is no need of again providing one more input. Okay, this is the output, and here as I said, it is output is equal to NAND means A dot B whole bar. As it is dot realization, both the transistors are in series. So A B. Okay, so this is VDD NMOS depletion, and this is NMOS enhancement mode. This is also NMOS enhancement mode. Okay, so Y is equal to AB bar. Okay, the output itself is a complemented form. If you have any doubt, you can check by applying zeros and ones. Okay, now if you take suppose, okay, we'll see the operation also so that you can understand in a better way. 0 0, why A is equal to 0, B is equal to 0. I already told you in the previous videos, the NMOS transistor comes into on state whenever we apply only 1 at the input. When we apply 0, simply it is in off state. So as both the transistors are applied with zeros, this is the pull down network is completely open circuited and output is connected to VDD. So output is equal to 1. And if it is 0 1, and we can remember one more thing, if any of these two AB transistors is in off state, simply there is no connection between output and ground. When there is no connection between output and ground, output is simply 1. Okay, here in this case A is off, in this case B is off. So in these three cases, simply output is connected to VDD. When both the transistors are applied with ones, means plus VDD, simply both the transistors are in on state and the static current flows occurs between VDD and ground. There is no flow of output current towards the output. So simply output is equal to 0. Simply this is nothing but NAND gate. So when we realize this particular operation, A dot B, simply connecting by NMOS transistors in series in the pull down network, simply it gives you AB whole bar. Okay, suppose if you want to design AND gate, then what to do? We need to connect one inverter again and then output is AB. Okay, so in the MOS technology, the output itself is a complemented form. We no need to connect inverter at the output for the complemented forms. Okay, now let us see the generalized structure or the main part of this generalized NMOS NAND gate. So in the generalized structure, we consider for n number of inputs. So y is equal to A dot B dot C and so on, n number whole bar. Okay, so what is the design in the pull up network? The design is common. In the pull up network, it is a depletion mode transistor, which is a channel here, which has a channel here. Here it is connected to here. So NMOS depletion mode, VDD. Now in the pull down network, output should be A, B, C and so on, n whole bar. Okay, how many inputs are there? N number of inputs are there. That's why n number of transistors must be connected in series, because number of inputs equal to number of transistors. So A, B, n number of inputs, and all these are enhancement mode NMOS transistors. Enhancement mode NMOS transistors. Okay, so simply y is equal to A, B, C and so on, n bar, n number of inputs, n number of inputs, n number of inputs. Okay, this is the generalized structure for a NMOS NAND gate. For NMOS NAND gate. Okay, suppose if it is a CMOS transistor, then what to do? In place of this CMOS realization, in place of this NMOS depletion mode, we connect n number of PMOS transistors in parallel. We connect n number of PMOS transistors in parallel, because NMOS transistors are said to be in series, then PMOS transistors must be connected in parallel. Suppose if NMOS transistors are connected in parallel, then PMOS transistors must be connected in series. So both are opposite to each other. Then only the circuit works. Okay. So the realization of the NMOS transistor only involves one transistor in the pull up place, and the remaining realization same. The bottom part of the CMOS logic circuit is equal to the bottom part of the NMOS logic circuits. Okay, both are same. Okay, I will write that point also. The circuit existed between VDD, between output and ground in CMOS logic circuit is same as the circuit existed between output and ground in where NMOS logic circuit. NMOS logic circuit. Okay, so bottom part is same. In the depletion mode, see, suppose here it is NMOS depletion mode. In the bottom part, we consider logic realization, logic circuit with NMOS transistors. So this is output. This is connected between VDD and output, and this is connected between output and ground. This is enhancement mode transistors. Okay, so in the next video I will explain about the transient analysis of this NAND circuit. Thank you.